Just stand here.
Yeah, this is fine.
Not in the way. All right, I'm Ivan Moore.
I'm Ren.
And we're going to talk about our experience introducing a continuous integration system that's not just a CI server, but a whole system to a company where we were both working. Ran's still there. I was brought in as a consultant to help.
Yep. So first up, we're just going to describe the situation before we started this project. So the situation is we were using Maven to do our build, and we're using fairly standard Maven conventions at the time. So, yep.
Yeah, so we had a whole bunch of components that were interrelated, and the dependencies were referring to each other using both pegged dependencies, so specific versions, and also snapshots in various different places. There's a mix of both.
And we
can I? Well, in fact, before we go forward, can I just check how many of you know Maven? Yeah. Okay. So,
okay. How many of you are using it? Still using it?
Okay.
Still.
Okay. Good. So it's it should be relevant to you.
Yep.
Although the same issues apply to other build systems too, where you've got components depending on other components. It's not totally specific to Maven.
Yeah. And one other situation, we had loads of branches, so more than 30, and that makes continuous integration quite hard.
Yeah, well, because there isn't integration where you've got branches. Yeah. We also had a special release build, which is sort of that's the Maven way. You have you use the release plugin and run a special build to create the release artifact. And that's what we were doing.
So just give you an idea of the size. So we arranged our projects into many top-level Maven projects. So we have over 50, and in terms of the number of modules, individual module, they are over 120. So it's quite large, and there's more than 1.5 million lines of code. So it is quite a large source tree.
Yeah. And the way it was structured was into...
I think there's a slide for this.
Oh,
yeah,
good.
there you go.
Into top-level reactors. So it was a bunch of these reactors. Are you familiar with the term reactor? So Maven multi-modules. So each of these have got multiple modules, and each reactor built a thing, not quite all of them, but most of them built an artifact that was then deployed and run on a server. So mostly these were sort of components that would run. Some of them were shared things as well.
Yeah, so actually, of the 50 modules, most of them are actually shared. There are, maybe 20 reactors containing a module whose purpose is to package them so that they can be deployed.
Yeah.
But one of the problems we had at the time was we had so many of these, and these are interdependent, and it was, the existing tools, it was very hard to make all the dependencies, work and or join up.
Yeah, and there was no super POM for everything because it would have taken forever to run. To run a build of building everything. So people would build the individual reactors.
Yeah. So so the problem that we talked about was that we did have a CI server at the time. It was Jenkins, but it wasn't really respecting the build order. So we just don't know what order it builds.
Yeah.
Because they were all snapshots.
Yeah, so it was building each reactor. There's a build for each reactor, but the order that those builds ran in was sort of random. Yeah, so if one reactor effectively depends on another, Jenkins didn't know about that, and so the order was sort of non-deterministic, and so you couldn't be quite sure what you got. So the feedback that we got was from the CI server was unreliable. It could either be falsely passing or falsely failing. And slow as well.
Yeah, and the problem was worsened because when the Jenkins server ran the job, each job actually published the artifacts into Artifactory, which then get used by devs. So We didn't know what they were on the build server, and if the devs started using these snapshots, it just makes the problem worse because it's very hard to reason about what dependency you're using.
Yeah. However, developers, they're very experienced, and we're used to this, and so they just knew the right order to run things in and knew which reactors they needed to look at. When I say new, of course, sometimes they were wrong or made a mistake. So they'd build, they'd know, oh, to build B, I know I've got to build C. So I'll build C and then I'll build B. And, sometimes they'd miss that actually now there was a dependency on D as well that they weren't sure about or didn't know about.
Yeah.
That sort of thing. So it's quite error prone, and you had to know a lot in order to know what builds to run. So it wasn't very friendly to newbies like when I joined.
Yeah. So yeah, I mean, the devs, in terms of doing a local build, we need to know what order they build. And again, the tools available are just not good enough to make that happen. And and because some people, they work on a project for a long time, they just know the order, and they would just, go to the right direction and do build. After that, go to the next one, build the next one, so on, until they get the final thing. But that wasn't very repeatable.
And we mentioned earlier there was a special build to build release artifacts. Release build, which is quite common in Maven land. But we'll get onto why that's a bad thing to have that separate build. But independent of that, even those builds were only run on developer machines. There wasn't a CI server running those builds, so a developer would run that release build on their machine. So it meant if they had things installed on their machine that other people didn't have, and somehow that affected what got built, you could end up with unpredictable artifacts.
Yeah, and also because it's so hard to build this, and each thing was versioned itself. Like every component has their own version. It means that developers are reluctant to update their dependencies. It could mean that some dependencies are a month out of date.
Or more.
Or more.
There were some that were
a year
6
out of
months,
date.
year out of date.
Yeah.
And the other effect of having these peg dependencies is that it was very hard to refactor, because if you made a change to one component that some other component depended on, if it depended on a pegged version from the past, of course it would be unaffected by those changes, so you wouldn't notice that your refactoring meant it needed changes somewhere else. Yeah.
Yeah.
So, and it was, if you wanted to make those changes and make some changes to some component that and the things that depended on it, it was really hard to sort of hunt around, find all of those places, update all the versions and all that. It's just really hard work. Are you all familiar with this?
Does that make sense?
Yeah.
Yeah. So and
all
all of those things make it quite easy to just break the build.
Yeah.
And when they do break, because they can break in so many different ways, it meant that developers just didn't take notice of them. They would just say, yeah, it broke because that thing wasn't updated, and I'll sort it out later. So sometimes the build can stay red for a long time.
Should we do more slides, or are they later?
They
to
are
explain.
probably later. That's later, I think.
Yeah. So we could talk about it now.
Yeah.
We mentioned about the dependencies between the reactors. So what we're talking about is, so these are multi-module projects. So this module in here has got some dependency on some other module in some other component, and so that means that the whole reactor, as far as we're concerned, you can consider the whole reactor B to have a dependency on the whole reactor A. Yeah.
Yeah.
Okay. So I thought it was just worth doing it at that point. So there were when we started working on a solution to these problems, we had sort of set of axioms that we wanted to stick to. So one of them was that we wanted to do continuous integration. And by continuous integration, we mean continuous rather than only, at certain points. So if you've got a special release build, that isn't continuous. It's got to be on every commit. And integration, that is, you can't have peg dependencies because that's not integrated. You're not integrating against the latest thing. You're delaying the integration of those things. So continuous integration was like one of the fundamental axioms of what we wanted to do.
Yeah. So another axiom was that we definitely needed fully deterministic build. So not just some random snapshot that the server generates and you can't trust, but it needs to be fully deterministic and repeatable.
Yeah. And also fast as well. So whatever we did, we had to be able to get feedback fast and build the artifacts quickly.
Yeah, and yeah. So in order to do proper CI and have something that you can deploy, every commit should result in a release candidate. So, and that's we don't have that before we implemented system. So that's another axiom.
Okay, and so there are lots of things that we didn't do, but we'll just talk about the most popular things that other people do that we didn't do. So one of them is we didn't have a super POM. And the reason for that is like for everything, because that would mean that you'd only be able to run the build on one build agent. Your CI build would be stupendously slow.
Yeah. So by having a super POM, you effectively treat your code base as a single project, and you'd have to build the whole thing in one shot by Maven. And to us, that was just not acceptable.
Yeah. Didn't meet our fast criteria.
Yeah. Other thing we didn't do was we basically banned snapshots completely. So yeah. So on the build server, the concept of snapshot just doesn't exist. And we also stopped publishing snapshot to Artifactory. So inside our binary repository, you'll never find anything with a snapshot.
Yeah, because you don't know what you've got.
Yeah. So it's one of those Maven concepts that at the time it was people thought it was a good idea, but actually it wasn't. It doesn't quite fit to in this continuous delivery model.
Yeah. Did you add one for semantic versioning?
No.
No. Okay. So similarly, there's sort of lots of people talk about semantic versioning, but to our way of thinking, that's just the same as snapshots. It's like a more refined version of snapshots. You don't know exactly what you've got, and we want to know exactly what we've got. Yeah. So it's got to be 100% repeatable. Yeah.
Yeah.
We also didn't. When we talked to people about what we did, they said, "Oh, can't you just put the commit ID in for the version number? Just put that in." And well, you sort of could, but what it would mean is you'd have to rebuild everything for every commit, and that wouldn't meet our fast criteria.
Yeah.
So what we did's a bit more subtle than that, and means that you don't have to rebuild everything. You only rebuild what's changed.
Yeah. So that's all of our axioms. And now we'll talk about our approach. So the first thing we're going to introduce is so basically instead of this peg dependencies, you're treating your own module as if they were third-party software. We wanted to switch to a model where you build everything from source, and we call it source dependencies.
Yeah.
So I don't know does that term mean anything to you?
Yeah.
So imagine this is your project structure, and I want to build reactor C, which depends on A and B. So if you're building everything from source, you would check out the source tree and build C such a way that A and B also build, and reactor C would depend on the jar produced by A and the jar produced by B exactly at the time you build. So it's as if everything is one version.
Yeah.
And you never depend on, for example, a version of B from 2 weeks ago.
Yeah. Or even 2 commits ago.
Or 2 commits ago.
It's exactly the same.
It's one version for the whole source.
Yeah. So it's as if you've only got, well, I mean, you have got one source tree. It's as if you're building everything. Yeah,
Yep.
it has exactly the same effect as if you're building everything.
Yep.
Yeah. So that was one of the things that we said. You know, developers had to build everything on their machine. We got rid of this getting a snapshot build off that the build server had built because you don't know what you've got. I mean, you know, the developer could have made some changes, could have done their pull, you know, at some time previously. You know, it's got to match. What you build has got to match exactly what you've got on your machine. Otherwise, it's not going to behave like you expect. Yeah.
Yeah. Okay. So yeah. So that was the approach. So the approach was to switch from the peg model to the source dependency model, where you treat everything in the source as one code tree. You know. But to do the switch over, there were some team concerns.
Yeah. So
And the first one was that, you know, if we don't peg dependencies, then everything would break, because, you know, there are so many. We're sharing so many components, and if you don't peg something to a stable version that was produced in the past, and always rely on the latest, wouldn't everything just break all the time? So
Yeah.
that was one of the concerns at the time.
yeah, and the sort of the thinking behind that is like you don't want to take someone else's changes. You know, that's what people are thinking. Yeah.
Yeah, and similarly, you know, if you know, we don't want to fix other people's code,
Yeah.
because if I change the shared API and change it in a way that makes my module work, why should I go in and fix? You know, there are 10 other modules that depend on the thing that I changed. It shouldn't be me who's changing it. It should be whoever's working on them. When the time is right, they change it.
That's what people thought.
Yeah.
Yeah. I mean, essentially, they didn't want continuous integration. They deliberately wanted to delay integration. That's how people were thinking.
In the name of, you know, stability.
Yeah. Also, there was a fear that because, you know, we were saying you've got to treat it like it is a single source tree. So previously, people just had the bits that they were interested in checked out or loaded in their IDE. We were saying, no, you've got to have everything checked out and everything in your IDE. So when you do a refactoring to some shared component, that's got to, you know, apply all over the code base. Yeah, so people were worried that the IDE just wouldn't be able to cope, that it would be too big and the IDE would be too slow.
Yeah, and also, like, because we said, if you want to have a deterministic, repeatable build, you're going to have to build everything, you know, always on the local machine, and that will be too slow.
Yeah.
And that's something that people feared.
Yeah, so
Yep.
that's all the fears. So it turns out, you know, we addressed all those fears, and we'll talk about what we actually did. So I don't know why you're giving me this one, because you did this. You personally
Right.
did the
Well, we did it together.
after this.
Right.
Ran did a proof of concept. This was just before I joined, to show that this could work. So it was on a subset of the code base with sort of manually configuring everything and just sort of experimenting and working out that it would work. Yeah.
Yeah.
Before we dived into do it for real.
Yeah, it's worth mentioning that we switched from Jenkins to TeamCity because TeamCity had this wonderful feature called snapshot dependency. So you can very easily model the dependency between components, and it will work out the build order and parallelize them. And the second thing we did was, and that took a few weeks, was to speed up the local build.
Yeah.
Just anything that can speed up the local build.
Yeah. That was without doing any of the sort of clever stuff we're talking about. Just keep it within the existing structure. Just optimizing the existing Maven build before doing anything cleverer.
Yeah, which
And
means removing any unused plugins.
Yeah.
You know, that kind of thing.
Yeah. Really important. Really important. I mean, by doing that, of course, it meant everything we did after that was faster. You know, like the changes we made after that were faster to do. Sort of the first bit of cleverness that we did was we wrote a script to work out, in fact, next slide. We wrote a script to work out what this dependency order was. Yeah, so we wrote it in Python, parsing the POMs ourselves. I mean, Maven just doesn't help you, actually, do this. Maven can tell you at the module level, but it doesn't know anything about at the reactor level. So we wrote our own script to work out the reactor level dependency tree, and got it to output dot, to do a graph, and you could see the graph, and it was like, scary, with all the dependencies.
Yeah. And to build upon that, we then had a script for running builds in the right order. So so once you have this sort of directed graph structure, you can just sort them. Topological sort will give you the build order, and that's exactly what we did. So having that script means that even for a person who's not familiar with the project structure, they can just run the thing, and then it will build stuff in the right order. Yeah.
So you no longer needed to just know what the order was. You could just run the script, and it would run the right things.
Yeah.
And we used that script to then set up the CI server. In this case, Team City. So we used that script, generate the DAG of the dependencies, and then using the REST API, set up the CI server with the builds, a build per reactor, and the setting the dependencies between the builds. Yeah, and in Team City, it's great because if you tell Team City what the dependencies are, it'll build the right things in the right order. It does the transitive dependency tree.
That's right. Yeah. So locally we use a Python script to do the local build, but on the build server, we only need to set up the jobs in Team City, and one reactor maps exactly the one job in Team City.
Yeah.
And then the Team City will work out the right build order.
Yeah.
Which is nice.
As long as you just tell it the dependencies. Yeah.
Yeah. And then we began incrementally unpeg components. So the pegging of component was considered to be a technical debt, because the dependency tree was very deep, and some dependencies were a year old, some were 6 months old, and it would take effort to bring them up to date. So it was actually a team effort.
Yeah.
Everyone was involved in trying to bringing dependencies up to date and making it compile.
So that was still before we'd actually switched over to using our new scheme of things. So the the script that we did for setting up Team City, that was still with a mixture of pegged and snapshot dependencies in the build. So strictly speaking, the build order was more conservative than it needed to be, because it might have been that you had only pegged dependencies, in which case you wouldn't have to do it in that build order. So we had this build. We knew that it was at the very least correct, even if it wasn't optimal, we, the whole team worked on getting it closer towards our goal, which was to have everything on the same version. So bringing all of the peg dependencies up to date. Yeah, it was quite a big team effort. The other team effort that we did was getting help from everyone to reduce the number of branches. So there's a huge number of branches, but we sort of drummed it into everyone. That wasn't integration, and with management support, got the number of branches gradually chopped away. Before, because we wanted to get all of that sorted out before we did this big switch over to doing our source dependencies thing. Yeah. Yeah,
and to manage everyone's expectation, we held many sessions to talk about the new model and why we thought it was better.
Yeah, and that's where we heard people's concerns that we mentioned earlier. We also trimmed the repo a bit. There were some things in there that were obsolete. They'd just gave it a bit of a clean up, and our scheme of handling all of these interdependent things, it only really matters for things that are interdependent. If they're completely independent of each other, you can build them without worrying about the stuff that we were talking about earlier in the dependencies. If there is no dependency, if you've got F that has no dependency on any of these, there's no need to have it in the same repo. So those things that were totally 100% independent, we sort of carved off into another repo to reduce the size of the repo that we were dealing with.
Yeah. So, oh yeah, have we gotten to the glitches one? What is that?
No,
oh, okay.
I don't see a heading for that. But
okay. Yeah. So, one thing that wasn't, one functionality that you don't get with, the tools that we used was cleanup of Artifactory because we're not producing snapshots and we're not expiring build artifacts based on some sort of expiry date. We're actually building release build
for every commit.
For every commit,
yeah.
We had to write our own purge job, and what it did was it matched what's in Artifactory to what's in TeamCity. Yeah. So TeamCity has an automatic purge job, so we purge any builds that were older than 2 weeks, and then we run our job that looks at TeamCity to see what jobs remains and go into Artifactory and clean anything that shouldn't be there.
Yeah. So if you wanted to keep a build, you could, for example, pin it in TeamCity or whatever. The TeamCity was the master of what builds needed to be kept. Yeah. And it's a shame, but yeah, we had to script our own stuff for cleaning up Artifactory. We also added support for doing patch branches. There was some concern when we were talking about our new way that we wanted to do things, that if someone needed to make a change to something, an emergency fix, they wouldn't be able to do it because with everything being integrated all the time, everything would be changing, and they wouldn't be able to get something stable. So we introduced sort of very, very easy support for doing a patch release. So in other words, taking a branch from some point in the past and and building that and just doing fixes to that. Yeah, fairly standard, but
but it was very useful.
Yeah.
So and after all that, we then did the actual cutover itself. And the actual cutover process was really trivial because we've done a lot of preparation in advance. The actual cutover involved us committing a few files, and that was it, really.
Yeah. So although that was really trivial, the whole process for doing the cutover wasn't. It was actually quite a big deal because we wanted to re-release all of the apps just to be really, really sure that everything was now working correctly, integrated against latest of everything. So we had some things that had previously depended on really old versions of their dependencies. They were all now fully up to date, and so to make 100% sure, we wanted to have everything released. So we had a clean baseline of everything being up to date with everything. Yeah, and that took quite a long time.
Yeah, so it's worth mentioning, like, we don't just have 1 or 2 applications that we deploy. It was actually 20 odd.
Yeah.
So that made it difficult because in order to make sure that the newly continuously integrated code base works in production, releasing all of them is something that we just had to do.
Yeah, and perhaps we should fess up as well. That this is like quite an old code base, and some of the components didn't have much in the way of automated testing. So there had to be manual testing of some of the things to check that they were all okay.
Yeah. And also during the cutoff period, which actually lasted 3 weeks, we noticed because we're now continuously integrating, every commit causes effectively new build. The builds are running at much frequent basis, and a lot of tests were just flapping.
Yeah.
Because due to the usual suspect like thread.sleep, this sort of thing, where before they were only built maybe twice a year or once a week or whatever, but now they're literally building multiple times a day, or for frequently working component, they're building every commit, which can be 20 times an hour.
Yeah.
And we noticed that some tests just not very good.
Yeah. I guess it was especially for the components that were the most depended on, the ones sort of the most shared components, previously people were reluctant to change them, and once we had the new scheme of things, they were much, much easier to change, and so they did change a lot more often, and so they were built a lot more often. The other thing perhaps to mention is that previously people didn't take as much notice of the build being broken as they should have done, because it was fundamentally unreliable. Sometimes it would break and there would be nothing wrong just because it had built in the wrong order. So, with our new scheme, it was definitely deterministic and, doing the right order. So if it broke, you knew that there was something wrong. Yeah, so people took more notice of it, and so these, flappy tests became more of a problem.
Yeah, so, the solution was just to fix all of them.
Yeah, and we got...
they were fixed.
Yeah, and it was... we got fantastic buy-in from the CTO, who really, emphasised to everyone this is really, really important to get rid of these flappy tests. So it was a big team effort to do that. Onto the subtleties.
Yes.
Yeah. More slides. It says here. It says slides.
Oh, is that a slide?
Yeah.
That's right. Yeah.
That's
that slide.
So yeah, in the source that developers have on their machine, it says snapshot. It looks as if you're using snapshots, and actually, when you build locally, you're using snapshots because it's only building to your local repo. So it's fine to use snapshot because you know that what you've got when you build it in the right order is the same commit as it's the source that you've got on your machine.
Yeah, and notice that we just call it integration snapshot, and there is only one version, integration snapshot. So we don't use conventions like 3.0 snapshot. There's no such thing. Yeah. There's only integration snapshot. That's for everything.
And we don't really like the name, but that's just what Maven wants. What we really mean is this commit, or what's on my machine in the case of a developer. On the CI server, those versions get rewritten into an actual version. Yeah. We're going to talk about where that version number comes from. How are we doing for time? Do we have enough time to go into that? Anyone looking at the time?
5 minutes.
Okay.
Okay. Well, okay. We won't talk about where the version numbers come from then.
Okay, fine. So yeah, basically the subtlety here is we have to manually do on the CI server. There's a step that does the transformation, and it's a tool that we wrote to do that because the existing tools just didn't do it, or didn't do it properly, not in the way that we wanted. Okay, this is the final slide. So we mentioned earlier that we want to treat the whole code base as if it's a monolithic code base, a single code base, and we're logically building the whole code base all the time on every commit. But what actually happens is when you commit, not all the builds build all the time, because with Team City, and if we set up each job such that it only looks for the relevant part of the source tree, you get incremental builds. So in this diagram, you've got these projects with the arrows indicating dependencies. So obviously A is something that everything depends on transitively. So if you changed A, then everything needs to rebuild, and you kind of run away from that. But if B changes, then you only need to build anything that really depends on B. So you're building the transitive closure. So B, D, E, and F needs to rebuild.
It's probably also worth mentioning, we forgot to talk about this. Of course, we've got loads of build agents, and these are all individual builds. So if there's a change to A, B and C are going to build in parallel on different build agents. Yeah?
Yeah.
And when B is finished, D will start running. When C is finished and B is finished, E will start running, and so on. Yeah. So you get builds running in parallel, and that's where you get the speed from. That's the massive difference between what we did and having a super POM. Yeah, we've got lots of build agents running lots of builds.
So end result was it was really fast.
Yeah.
Yeah.
And also because of the scheme that we took, it means you can build a you can reproduce a build for just with a commit ID. All you need is the commit ID, and you can rebuild everything.
Yeah,
Yeah.
And in order to reproduce everything from a single commit ID, it was necessary to have all the code in a single repository.
Yeah. Well, and having all the code in a single repository, you have to have in order to know what you mean when you say, that depends on that the same commit version in the source. Yeah, it's sort of fundamental that everything has to be in one repo, because what you're saying with your versioning is the same commit. I depend on the same commit as this other thing. Yeah, if they're in different repos, how do you do that?
You have to stitch them up. There's another, another layer.
Okay, shall we talk about the effects that this had? So we introduced this. We mentioned the developers' concerns earlier, but the actual effects that introducing this system had were there was a lot more restructuring of the code base. Once we introduced this, it just made it so much easier to change things, especially the shared things, that happened a lot more.
And the developers were more responsible for code changes, because now they know that whenever they touch a shared component, if they do something wrong, it will affect everything. And immediately they'll see red, the build motor going red, and therefore they're more careful when changing them.
Although I think some people sort of think that having peg dependencies might give you better thought out APIs, because it's more sort of like a definite thing that this is the thing that you depend on, and so we'll think really hard about the API for that. What we found was actually the APIs for some of the shared components were not that great, and the reason they weren't great was because it was really hard to change them. Once we introduced the ability to change them easily, the APIs got much better because refactoring them was much easier.
Yep.
Slightly counterintuitive.
It's sort of counterintuitive. I mean, I think it's sort of the Facebook model as well.
Yeah.
That's what they do. They do everything to facilitate change. If there's anything in the code base that doesn't make sense, then do everything to facilitate changing it, rather than making it static and make it not impossible to change. So we found that actually by giving the power to everyone to change anything, anytime, it meant that the APIs were actually better designed, and the modules were arranged more logically.
Yeah.
And another effect, which is quite related to this one, is because we have the dependencies modeled on TeamCity, and TeamCity building in the right way, people took notice of the build order, and they noticed some builds were slower than others, and they actually went in to each project and ripped out any unneeded dependencies.
Yeah.
So optimized the tree.
Yeah, it's because people would say, I've changed this thing, and my thing hasn't built yet, and why is that? And then they'd sort of follow the dependencies and see that actually it was depending on some other thing, and realise, well, it doesn't need to depend on that. If I get rid of that, then it'll build earlier, because it's doing it's following the dependency tree. So if you realise that actually E doesn't need to depend on B at all, that's like some obsolete thing that you've now changed. Now, when B changes, that doesn't trigger a build anymore. Yeah. Or if B's really slow, you're not waiting for B to finish, you're only waiting for C to finish before E builds, that sort of thing. Yeah. So people really notice that with the new system. Also, we got rid of any possibility of diamond dependencies. Are you all familiar with diamond dependencies? So if you've got, in this case, if C depended on some version of A and B depended on some version of a different version of A, what's E going to get?
You don't know. I mean, it's sort of, unless you lock it down, you just don't know. I mean, it's some order that may even decide for you.
Yeah. it tries to be helpful, but you know, you want to know for sure. And with our scheme, because you know, C is depending on the same version of A as B is, you know, and D. Everything's on the same version.
Yeah.
Yeah,
So
which is
there's
just
no
the
diamond
source as
dependency
it
at
is.
all.
Yeah,
So that's an entire class of problems just gone. So so before the model, we did have the problem, the occasional problem of running into, you know, runtime exception, like this class was not found or that method doesn't exist, and it's because of diamond dependency. So this is actually much safer. So that's it. And yeah, we encountered just a few glitches on the way. So one of them was the actual the cutover period. It lasted 3 weeks, and during that 3 weeks, basically we did nothing except doing the cutover. So, you know,
it's a real
had to
shame.
stop the business.
Yeah.
But it was something that just had to be done.
Yeah, we really wanted to avoid having to have any sort of big bang. We tried to do it as incrementally as we could, but that was, I mean, it could have been worse. It could have been
a lot
longer.
worse. But during that 3 weeks, we did release every application and fixed all the tests that were flapping.
Loads of flappy tests,
So
which is good.
Yeah.
We automated everything. You know, we talked earlier about we had the script for configuring Team City. I should mention as well, actually, there's a Team City job that runs that script. So, you know, Team City configures itself, and then if the modules change, it reconfigures itself, you know, and creates the right projects and so on. We also automated the provisioning of the actual Team City server and agents and all of the other stuff as well. But for that work, there's like a separate ops team, and that was a bit tricky at times.
Because they were separate to development team, and communication
Exactly.
was sometimes.
I think we forgot to say something that was quite important. Although there again, I've got a very bad memory, so maybe we did. But did we mention about, one of the fears was about the IDE being slower, and actually it was much faster, having done this, because previously, when there were all these pegged dependencies, what you actually ended up with was 16 versions of A in the IDE, because so many different components and all of them pegged to different versions. You'd end up with loads and loads of versions of loads of the components. Doing the scheme that we went for, there's only one version of everything, and so there's actually a lot less for the IDE to deal with. So it's actually much faster.
Yeah.
And perfectly possible to do refactorings across the whole code base. Absolutely no problem.
So the end result is, yes, it was entirely possible to have 1.5 million lines of code in the same IDE, and it's pretty snappy.
Okay, I think we've covered everything. So.